Good morning, everyone. Today we are going to discuss how we are going to transcribe and then dialyze the audio signals into text. What is basically speech transcription in which we convert the audio into text? So, there are certain processes that are involved in transcribing an audio into a text. First of all, we have to convert the audio into mono, and then we have to sample it according to 16,000 hertz, and then we have to check the bit rate, like it could be 16 bits of information that is present in the signal, and then we pre-process, remove the silence, detect the activity present within the signal, and then try to remove any kind of noise, high frequency signals from the audio. Now, in today's lecture, in today's tutorial, what we are going to see is we are going to use WhisperX with Nemo, and Nemo is NVIDIA new package that will help you to dialyze the speaker into number of speakers that are present within it. So I have evaluated in this algorithm into number of audio signals, and what I have observed that it's performing quite good. So there are various model in a fast WhisperX. So I'm using large V2 because it's performing quite well on my audios, and the system that I'm using is 3090, RTX 3090. So let's deep dive into this process, and let's see how we are going to do it. First of all, I have installed all the dependency that are required for execution of this model. So I'm running it for Python 3.11, and you may check with respect to environment or with respect to your system. So I'm going to launch it in Jupyter Notebook, and let me let me execute it. So these are the basic requirements. So we have to install wget and Nemo, and Git is also required. You have to install Git in your system. You have to install NLTK. You have to get these Git repositories, and then you have to install Perl, Strawberry Perl, and then you have to install. I will list down all the dependency, all the requirement that are needed for installation, and then let's see. After doing that, I'm going to see in this. I'm going to import all the packages that are needed. So I'm importing OS, wget, Omega Conf, JSON, Torch Audio, Nemo. So this is I'm using it for diarization and the deep multilingual punctuation. In case in some languages punctuation support is also available, we will see it support English, French, German, Spanish, Italian. So these languages are being supported by this, but unfortunately, Urdu is not over here. And in this tutorial, we are trying to transcribe the Urdu call, and then we this is for regular expression. This package RE is for regular expression. Logging NLTK is one of the most promising natural language toolkit, and then we import faster whisper. So I have executed this command. So this direct mean that it's started processing and executing and trying to import. So if one is present, it means it's been executed. Then I have initialized these parameter and some processes, some functions also. So in this, what we are trying to do is basically we have initializes the languages with their language code and ISO codes are being initialized in the helper function. And then here we have passed these language key in the whisper model. And then we have defined a configuration function in which we uh, told the model that we are basically dealing with telephonic conversations, and then it may check this name of the model, and then it will fetch this from this repository, and then download it as an offline in the system, and then it will pass it to the function, and then it will going to load it, and then it will check where the data is being present, and if there is no folder is present, it will try to make one. And then this is basically the template which tells the model that all the files that are mono files, they have no offset, duration is none by default, because we are basically passing the parameter in the constructor. Label is info and text is dash. Initially there is no output, so we have given as dash. And so it basically we have just created a template of these variable that are needed in the model. So then if there is input manifest file is being present, it will going to get it and write it. And then voice activity detection is being performed using MarbleNet, and it is already a pre-trained model. And then to dialization, we have used TetaNet large. It will help us to dialyze the number of speaker that is present in the audio signal. And then after dialyzation, we have initialized some parameter like onset, offset, paired offset, model path is also there. And this is basically for telephonic conversations. And then we define some anchors like end, mid. So these anchors are being defined. And then get the work. So in this, words are being mapped according to the speech. So this function is basically doing this. And so all these functions are basically the helper functions to detect the words and to align it with required punctuations and get sentence mapping with respect to audio. And so all these functions are there. And then this function format timestamp, it will make a consistent timestamping mechanism so that you can track back to any part of the audio. And then you are going to write, this function will help us to write the transcribe into a text file. And this basically tokenizers, which will break the word into parts, and it will break the sentence into different word level tokenizations. And this is how it will going to work. And filter the missing timestamp. It will perform cleanup, process language argument. So that is how it will going to work. Now in option for this model, we have given the path of the audio. So I have given this wave file in my local folder, and then I enable stemming. Stemming means to remove any kind of uh, punctuation that are present, and after transcription, it will convert and align it with respect to required punctuations. So I'm using a Whisper uh, large V2, and this is Whisper X, and then suppress the numerals if there are some digits are been present. So um, it will remove it. So this will help to improve the accuracy, and batch is 8 because we are running it on GPU 3090. So a lower batch size will improve the accuracy. If you increase the batch size, it will miss some words. So smaller batch size help the GPU to detect the words with more accuracy. Here you can enter auto detection as well. But if you are not getting the required accuracy, you can enter the language that has been already known to you. For example, if you're transcribing for the Urdu audio, so automatically you will write you are over here in term of parameters. So there are various short symbols for languages. So you can check the documentation for WhisperX. So there you will get it, and these options are also present over here, like we have already described in the beginning. So these are basically the short symbols that are being required. So see, for Urdu we are using UR. So it will already been defined in the on the language model. So see, Urdu is UR. That's how I know to pass this parameter in the model. Okay, after doing that, after I think I have executed this one, let me check it if there is some number is been appearing. Okay, so it's already been executed. Let me run next. Okay, let me run this one. So now it's running and there is no error for CUDA. So it means CUDA is available. Now I'm going to run stemming. Then I'm going to initialize my model. See, I have entered the data type for updating the weight as float 16. So you can also write int 8 if you're using GPU, if you're using CPU. So, and the model is faster Whisper, and device type is CUDA. CUDA is for GPU, and you can also pass language in it, and then we define the pipeline for the Whisper. So it will be in term of a batch inference pipeline, and we are going to pass this model into it, and it will decode the audio, and then it will pass this, and then uh, it will going to transcribe using a batch of 0, else this, and then after running we will going to empty our cache. So let us align it further. So what does alignment mean? Basically, alignment is actually let me check where is their error. Okay, it cannot able to find this file. So what we are going to do is we will check. Okay, we will rename it. Instead of this file, I'm going to pass this file, and let's see how it's going to work in my where I have given. So here I'm going to write the name of the file and run it. Now it will going to work, because once your system try to uh, transcribe and the file is not over there, then it will going to make a mess. So it started executing. So we are here. It executed this one. Now this cell is being executed. So what is alignment? Alignment is basically align with respect to original audio, so that once force alignment aim to align transcription segment with original audio since contain the vocal target. This process involves finding the exact timestamp in the audio signal where each segment was spoken and aligned with text accordingly. By combining the output of two models, the code produce fully aligned transcription of speech contained in a vocal target. This alignment can be useful in variety of speech tasks such as speaker diarization and sentiment analysis and language identification. So that is how it's going to work. Now, in this, we are defining um, that we are performing the diarization and initializing our model. So we are using Nemo, and Nemo will going to, so we have initialized this one. Now we are going to run the Nemo model so that it may start diarization process. So we are using MSDD, so which is multi-scale diarization decoder to perform speaker diarization. Diarization means segmentation. When two speakers are saying, so their transcription should be separated with speaker one, speaker two, and whatever speaker one said, it will be labeled as it is being said by speaker one. And whatever is being said by speaker two, it is being labeled as this word or this sentence is being said by speaker two. So that's how this multi-scale diarization decoder for NVIDIA NeMo is being performing, and it is separating the audio signal into different segments on who's speaking at given time. So it has performed its job. Now let's run this one, and let me run this one also. And at the end, we are going to run and write the file. So it's already done. Let us check. You see, two files are being created. One is this one and one is that one. So let me open this. You can see that with proper timestamp, it has been dissected and said that speaker 1, Assalamu alaikum, speaker 0, आप तशरीफ नहीं लाई, speaker 1, मैं तशरीफ क्या लाती, मेरे husband कह रहे थे कि मैंने आपके साथ जाना है. So see how it's going to uh, uh, converted the speech into text with respect to timestamp and with proper diarization. So how it's going to perform. So, and you can see it's also performing multilingual. So there are two kind of languages that are being spoken in this, and it has the capability to perfectly write them into their respective text. So that is how it's going to. So I think it has done its job and performance is quite well. Thank you so much for listening me. So that was the tutorial for today. Going to